Here we go. Hey everyone, Norman here with the McWane Science Center, and welcome to Sci Sparks. I'm sure you're wondering what we were about to do just then. What was that strange device, and what were we gonna do with those dishes? Well, stay tuned to get the buzz on a pretty neat electrical invention. Have you ever dragged your feet across a carpet in a comfy pair of socks just to get a painful zap to the finger when you reach out to touch a metal doorknob? Chances are you have, which means you're probably well acquainted with static electricity. See, static happens when an electric charge is built up thanks to something called electrons. Here's the thing though, charges come in two types, positive and negative, and they interact based on which type they are. For example, two charges of the same type will repel one another, whereas two charges that are different will attract one another. Electrons have a negative charge, and this means when an object gains electrons, it grows more negative in charge. Conversely, when an object loses electrons, it grows more positive in charge. This handy device right here is known as a Van de Graaff Generator, and it makes use of the exchange of electrons between different materials in order to explore some of these properties. The device was named after Dr. Robert Van de Graaff, an electrical physicist and 1920s graduate of the University of Alabama. Inside of our Van de Graaff generator, there's a belt running between two rollers made of different materials. The upper roller, inside of the metal globe, is usually made of a material like acrylic, and it readily donates its electrons to the belt as it runs across. Meanwhile, the lower roller, down here, usually made of a material like Teflon, readily accepts those electrons. Over time, this generates a positive buildup of charge in the metal globe, while the bottom of the generator, often connected to a metal wand, generates a buildup of negative charge. The intense difference in charges can cause one of two things to happen. First, you can get sparks of lightning between the wand and the globe, and this happens for the same reason that we get bolts of lightning during a thunderstorm. And the second thing that happens is that anything that comes into contact with this globe when it starts amassing a positive charge will donate their electrons and start to amass a positive charge as well. For example, this stack of pi tens will begin to lose its electrons the moment the generator is turned on. As each pi 10 becomes more positive, it will start to repel one another and lift off. That effect can be scaled up using a much larger generator like this one. In this bigger generator, the electrons are pulled away faster and in far greater numbers, meaning that we get a greater buildup of positive charge all along the metal globe, which will result in an even more intense spark of electrons between this wand and the globe itself. So earlier, we saw what would happen if we put a few of these pi 10s on top of our Van de Graaff generator, but now that we have a bigger generator, I want to see what will happen if we add just a few more. Here we go. Now we've seen what static electricity can do. As our generator created a lack of electrons, each saucer donated theirs. And since the globe and each saucer were becoming positively charged, they all repelled one another and took off, just like an alien fleet preparing for an invasion. We've only barely scratched the surface talking about static electricity today, but that's all for now. Thank you for watching today's episode of Sci Sparks, and to stay up to date on all of our content, be sure to subscribe to the McWane Science Center YouTube channel or check out our website at mcwane.org. Until next time.